In chapter 3, you learned how to solve linear inequality, but only one linear inequality. In this chapter, chapter 4, you're solving a system of linear inequalities. So let's talk about what a system looks like. You have two inequalities. What you're going to do is graph each one separately, and the region where they both intersect would be the solution to the system. So just like we did in chapter 3, you want to make sure that your inequality is either in slope-intercept form, or you may want to graph it using the x and y intercepts, depending on what you're given. So for this one, y is less than -1/2 x plus 2. Since it's in slope-intercept form, it's very easy to graph this. You would begin at 2 on the y-axis, and your slope is a 1-to-2 ratio, meaning you're going to rise 1 unit, and we're going to go 2 units to the left because it's a negative slope. So we continue that pattern, and you can go the other way as well, which you should. You should span the entire graph. And now we are going to connect these dots with a broken line because it's not including the equal to sign is not there. So broken line. And because it's in slope-intercept form, like chapter 3, it's the less than sign. We're going to shade less than would mean below. So all of the points in this shaded region satisfies this inequality. So the next inequality, you can do one of two things. You can find the x and y intercepts because it's in standard form. So if I plug a 0 in for x, y would equal -4 because you have to bring the negative over, okay? And if y is 0, x would equal 4. So 0, -4, and 4, 1, 2, 3, 4, 0. Now I'm going to connect these dots with a solid line because of the equal to sign, okay? Now, what you're going to do, you're concentrating on this line right here, you're going to shade above or below. Now, if the equation is in slope-intercept form, which this one isn't, so let's take a second and let's see if we get this in slope-intercept form. So bring x over, you're going to make it a -x, and then when you divide everything by -1, you're going to flip the sign, make that a +x, and this a -4. So let's double check. We began at -4, and the slope is up 1 over 1, up 1 over 1, and so forth. Now, the inequality sign is a greater than, so we would shade above. And we're looking at where these two regions overlap, which is this part right here. So everything in the area that is double shaded is a solution. So in other words, we have everything in this region that's not on the broken line, but the solid line, and everything in this region is the solution. These points satisfy both of these inequalities. Now, if you didn't know which region to shade, the best thing to do is to test a point. So back to this line right here, which is the second one. If I would have tested the origin, 0 and 0, so if x is 0 and if y is 0, if I plug 0 and 0 in here, 0 minus 0 is less than or equal to 4. So it was true. So that's another way you can do it. Next one. Okay, so for 3x minus y is less than 6, let's bring 3x to the other side, make it -3x. And then dividing everything by -1, you're going to flip the sign, make this a +3x, and then a -6. So we begin at -6, 1, 2, 3, 4, 5, 6, and we're going to go up 3 and over 1. And these dots will be connected with a broken line. And because this is a greater than sign, I'm going to shade above. Okay? Now for the second equation, or inequality I should say, when I bring 2x to the other side and divide by 2, I'm going to end up having a fraction. So for this one, I am going to do x and y intercepts. So if I plug 0 in for x, y would be 5 over 2, which is 2.5. And the same, if I plug 0 in for y, x is going to be 2.5. So you just need two ordered pairs to determine where the line is. So 0, 2.5 would be right there between 2 and 3, and 2.5, 0 would be right there. And now, so these 2 points, if I connect these and continue that pattern, I'm going to make a solid line because the bar is there, this bar right here, so it's solid. And it's, if I tested the origin, so here's my line I'm concentrating on. If I plug a 0 here and a 0 here, 0 plus 0 is not greater than 5. So this was the wrong region to shade for this line right here. So it's obviously the other region, which is that. So the solution would be where these two overlap, which would be this broken line, this solid line, and everything in between. Now to check that, you can plug any point in that's in the yellow region and it would satisfy both. So what happens when we do not have the x and y in both equations? Well, these are actually simple. What is y? Y equals -1. We learned in chapter 3, it's a horizontal line at -1. But for this, you're going to make it a broken line at -1. Why? Because there's no bar there. And greater than, you're going to shade above. And then x is greater than or equal to 4 would be a solid line vertical line at 4. And you're going to shade to the left because it says less than. And so the region that's double shaded would be this broken line and anything in this region. You want your solution to pop out at you. Okay, now here's some extra practice problems. Okay, so for number 5, what you're going to want to do is rewrite these in slope-intercept form. So if I bring 2x to the other side, I get -y is less than -2x plus 4. Divide by -1, but we have to flip the sign, don't forget. So it's positive 2x minus 4. This is that equation rewritten in slope-intercept form. So we begin at -4, and you're going to go up 2 and over 1. And we're going to make it a broken line. And we're going to shade, it says greater than, so we'd shade above. And the second inequality is already in slope-intercept form. We begin at 2, and the slope is -1. So it's up 1, over 1. And we're going to make this a solid line because of the equality. And it's a greater than sign, so we'd shade above. So the region that's double shaded is this solid and everything in between. Okay, next one. This one you're going to begin at 1, and your slope is a -2, 1. And we're going to make this a solid line and shade less than, which is this way. And this next, I'm going to start at 0, 0, because it's 0 is your y-intercept. And I'm going to go up 3 over 1, up 3 over 1, down 3 over 1, down 3 over 1. And this is a broken line. And it says to shade greater than, so it's going to be, I'm looking at the yellow line. So when I shade to the right of that line, the region that's double shaded is this in between here. It's very small. And for number 7, this one you're going to begin at -2, up 3 over 1, up 3 over 1. And this would be a broken line. It's a less than, so you're going to shade below. And the second inequality, start at 3 it's down 2 over 1. And this one is going to be a solid line. And when you shade, you're going to shade less than, which is down below here. And so the region that's double shaded would be this broken, and everything in between here. Okay, next. For number 13, what I would do, because it's written, this top inequality is written in standard form, and both 4 and 5 are divisible by go into 20. So I like the fact that since these two numbers go into 20 and it's in standard form, I do my x and y intercept. So if I plug 0 in for x, it's like saying that's not there. 5 times what is 20? And that would be 4. And if I plug 0 in for y, -5 times -4 is 20. So this is your y-intercept, 0, 4, and -5, 1, 2, 3, 4, 5. And I'm going to put a broken line connecting 2 points, determine a line. And now I'm not sure which side to shade because I didn't get it in slope-intercept form. So I'm going to test the origin. It's the easiest point to test. If I plug a 0 in for x, a 0 in for y, I get 0 plus 0 is definitely less than 20, so I'm shading below. And for x is less than or equal to -3, that would be a solid line at -3. And when I shade to the right, because it says greater than, I'm going to see clearly this is my solution, everything in that region. Number 14, this one, begin at 1, up 2, 3 this way, up 2, we're going to go to the left because it's a negative, but if I go down, I'm going to go 3 to the right, down 2 over 3. A solid line, and it says greater than or equal to, so I would shade above. And for y is greater than -4, it's going to be a horizontal broken line, broken because there's no bar there, and above would be like this. Now the region that should be double shaded would be from here, and then you don't see much of that, but it continues on, and you would shade up on top. Number 15 is easy. Vertical line at 4, solid, and you'll have one of these for sure on your test, so make sure you know them. Shade to the left, and y is greater than -2, solid, horizontal at -2, and you're going to shade up. So what area is double shaded? It is this right here. And the last one. So for 17, the first inequality, what I would do is I would definitely do slope intercept, or not slope, x and y intercepts for the first one. So if x is 0, y would be 5, and if y is 0, x would be 2. So 0,